Hi guys, this is Additional Mathematics Form 5 textbook question, Chapter 5 Probability Distribution for Formative Exercise 5.3. My name is Terry. If you enjoyed this video, kindly like, subscribe and comment to let us know how we can improve our video presentation. So let's get straight to this. So the first question, you're given a diagram that shows a standard normal distribution with the probability represented by the shaded region is 0.3415. So this area is 0.3415 and you're supposed to find the value of k. Now you can actually write this or represent this with this equation. You can see that your k is on the left hand side. So k is the biggest value, the smallest values, followed by z, followed by 0, and this area or this probability is 3415. Now we know that total probability is 1, and if you trim it half of it, this would be 0.5. So you can actually write 0.5 minus the probability of z less than k equals 3415. Now the 3415 is this area in between here. So to find this area over here, the probability of z less than k, we take 0.5 minus 0.3415. That will give us 0.1585. Now, to find the z value given probability, you have to use the mathematical table. Unless you have the 570EX class width, the black calculator. That calculator also can find the z value directly given probability. But for now, we'll just use the table. If you have table now with you, we know that if in order for your area to be 0.1585, by the way, please take note, the table is based on the upper tail. That means the z value must be positive and the area must be less than 0.5. At any point your area here less than more than 0.5, you can't actually find from the table. So you have to do 1 minus or 0.5 minus to get the probability to be less than 0.5. Okay, so we can see that this is actually on the right hand side, and your k value you have to find backwards from the mathematical table. Okay, and I got 1.001. Yeah, this is your z value on the right hand side. However, this k is on the left, so you need to flip it over. So when you flip it over, right, this is still 0.1585, but the z value here will be negative. Yeah, so just take note of that. So in this case, your k value should be negative 1.001. Yeah, as k is on the left hand side of 0. Okay, this question we're done. Let's move on to question number 2. So here we have x is a continuous random variable normally distributed with mean of 12, variance of 4. Now you can actually write like this: x is a normal distribution, mean is 12, variance is 4. You can write this, but please take note that this is variance. When you represent in this notation, it is variance. So you need to find standard deviation from variance by taking the square root of 4, which is 2. Okay, first part A. Find a z-score if x is 14.2. Remember, the relationship between x and z is given by this x minus mu over sigma, gives us our z value. So we take 14.2 minus your mu 12 divided by standard deviation 2. Here you get 2.2 divided to 1.1. Okay, so that is part A. So for part B, you're finding the probability that x is between 11 and 13.5. So here we have to standardize one by one. I think this is not related to part A. So we take 11 minus 12 divided by 2. Yeah, I'm using this formula here to standardize it. Remember, you cannot find the probability unless you change everything to z standard normal distribution first, and we use a table or even your calculator to find the probability. So this will be 13.5 minus 12 over 2. And this will give us negative 1 over 2 is 0.5, and this is 1.5 divided by 2, which is 0.75. Now, if I were to sketch this diagram, yeah, 0.5 negative is on the left hand side, 0.75 is on the right hand side, so this area is in between. And every time your area is in between, you need to use 1 minus. Now the 0.5 is on the left, you have to flip over to the right. Okay, and the 0.5 is on the right. over here. Sorry, my diagram is a bit too small. So we use 1 minus b z greater than 0.5 minus z bz greater than 0.75. Okay, these two values can actually read from your mathematical table, or you can use your calculator. Yeah, calculator will do this as well. So you get 1 minus 0.3085, and this is 2266. My answer is 4649. Okay, yeah, I think this is quite okay, right? Not difficult. Now, moving on to question number 3. So here we are given a diagram which it represents a standard normal distribution. Now we're finding the value of the probability of z less than m. Okay, z less than m is actually this area, right? Number one, I think we can do 1 minus, because you can see that the total area is 1 by taking 1, the whole thing, minus the probability less than m, which is on the left hand side here, probability more than 0.35, and I'll get the area in between, which is 0.5124. So let me write the equation like this: 1 minus bz less than m minus the probability z more than 0.35, and this area is 0.5124. Now I'm going to bring this over, or should I just calculate this? So let me calculate bz more than 0.35. This one you can use the mathematical table or your calculator. I've got 0.3632, 3632. This is 0.5124. By taking 1 minus the rest of this, 1 minus 0.3632 and minus 0.5124, I get 0.1244. Here you don't have to find an m, we can just leave it like this because the question only asks you for the probability of z less than n. Alright, let's move on to question number 4. So the masses of baby born in a hospital are normally distributed with mean of 3.1, standard deviation 0.3. So find the probability that a baby born in a hospital have mass between 2.9 and 3.3. Remember, the first thing is you need to standardize this. When you standardize, you need to minus your mean, divide by your standard deviation. So 3.3 minus 3.1, divide 0.3. Now, here's the thing, you may realize there's a difference between using the calculator directly versus using the mathematical table. Now, let me just say this, those who use, most of the time we would say use a mathematical table. A lot of teachers tell you use a mathematical table, but if you want to use mathematical table, you can leave it up to 3 decimal places, because you can't read z value that's more than 3 decimal point. So then you have to round this off to negative 0.667, and this is 0.667 as well. But if you want to use a calculator directly, this will be negative 2 over 3, and this will be positive 2 over 3, right? So now the textbook answer is based on using calculator directly, yeah, just so you know. So if you can see, this is in between, right? In between, let me use the one with decimal, 0.667, left and right. So yeah, I think the shaded region should be in between, sorry. So I need to do 1 minus, yeah, the whole thing is 1. I minus 2 times of the value more than 667. So I can write 1 minus 2 b z more than 0.667. And this will give us 0.2524, which will end up getting 4952. But remember, this is from the table. If you use 3 decimal places for your z value, you submit the table, this is what we get, which is different from the answer in the textbook, right? I think because the textbook uses this z more than 2 over 3, right? This value will be, okay, I need to times 2, sorry, I missed out the 2 here. Yeah, let me write down the 2 in front. 1 minus 2 times, so this is 2 times of z greater than 2 over 3, which is 0.25. You can write 2525, 2525. So this will be 0.4. 2525 is 495. 4950. Okay, so notice the difference if you use calculator directly. So Yep, that's why there's a difference between the answer. So I would say perhaps it's better if you use the mathematical table up to 3 decimal places here, right? Then your answer will be this. Yeah, if you want to use calculator directly and use 2 or 3, yes, your answer will be 4950, which is the same as the answer in the textbook. Okay, next. This is only part A. Part B, they say that 25% of the baby born in hospital are categorized as underweight. Find the maximum mass. So let's do a rough sketch, okay? Underweight means it must be the bottom quartile. We call it, in statistics, we call it lower quartile, bottom 25%. So we want to find the maximum mass. The maximum mass, or the cutoff to be underweight, let me just label as M, as you can see, is here. Now, we can write the probability of X less than M to be 0.25. Now, we know we have to standardize first. Here we take M minus mu. Your mu is 3.1, standard deviation 0.3. This is 0.25. Now, if you read from the mathematical table, remember, your mathematical table is based on upper tail. That is, if you read 0.25, you will get 0.674. But this 0.674 is on the right side, it's on the left hand side. So if you want to flip it over, then it will look like this. Let me squeeze in here, 0.674. You need to put a negative, is on the left, right? So this M minus 3.1 over 0.3 is basically negative 0.674. It's on the left hand side, not the right hand side. Sorry for the ugly drawing. Now, you just take 3.1 here, you plus 0. In this case, you minus 0.674 times 0.3, and your mass for the underweight babies will be 2.898. If you round up correct to 4, significant figure is 2.898. Okay, now we're okay with this, not too difficult. Let's move on to question number 5. So here we have a photo, yeah, that shows a fish reared by Mr. Lim. The mass of the fish in the pond is normally distributed. Mean is 650. Standard deviation is P. So if the probability that a fish caught randomly have mass less than 600, we write X less than 600 is 0.0012. Find the value of P. So here, okay, the first thing is I will standardize first. I'll change X to Z. I'll take 600 minus mu 650 divided by standard deviation P 0.0012. So when you standardize this is negative 50 over P 0.0012. Now again, you have a bit of a problem with the textbook. Is because if you use a mathematical table, right, I wonder whether you know, this is a low decimal point. If you read 0012 is quite lower. In the table, right, you will notice that there are 3 values that give us the same Z value, the same area under the graphs, the same probability. From the table, you will get 3.034, 3.035, 3.036. The question is, which one should I take? Now, for me, if you're given 3 values of the same, I'll take the middle one. That's the safest, right? Yeah. But if you take you get directly from the calculator, Casio FX570EX, the classic, the black color calculator, you will get exact value, right? Okay. Let me show you from the calculator. All right. You will get. Let me draw out for you. Let's say, because this is on the left hand side, so I'll just draw like this. First of all, from the calculator, if this 0.0012, I got 3.036 from the calculator, right? But you need to flip over. So when I flip over, this is the same 0.012, but we have to put a negative because this Z is less than. Now either you flip the Z over or you flip the, the value from the calculator over, it's the same thing, up to you. So you can write negative 50 over P equals negative 3.036. My P is 16.47. Okay, now contrast this with if you were to use a table, and I think the textbook uses the first value. That's why answer is different. The textbook uses 3.034. So if you were to do that, then you get negative 50 over P equals negative 3.034, your P is positive 16.48, which is given in the textbook, right? So I would say the correct answer is 16.47, right? Because if you have three values, I'll take the middle one to be safe, right? But if you use your calculator directly, it is actually 3.036. So your P value is 16.47. Okay, so just to take note that there's a difference between the answer. Okay, let's move on to part B. Let me continue part B here. I may have to like right below on the left, not enough space. So if 350 fish have mass between 645 and 660, find the number of fish. Okay, before you find the number of fish, you must find the probability that the fishes here, they have mass between 645 and 660. So we standardize 645. You minus your mean, divide by your standard deviation P. Now here, that's the thing. Do you choose 16.48 or do you take 16.47? So I'm just going to use 16.47 since this is supposed to be the more accurate answer, right? You minus 650 divided by 16.47. So this value that I've got is negative 3.04. Sorry, negative 0.304, and this is 0.607. Now remember, if your area under the graph is one is on the left, one is on the right, we need to do 1 minus, right? So I have to do 1 minus. The one on the left is BZ. I will just flip it over, change it to 0.304. This will be Z more than 0.607. And if you use your mathematical table, or even use calculator based on 304, you will get 0.3806 2719. I think the probability you just use 4 decimal places is good enough. Yeah, and once you minus, you get 3475. Okay, however, contrast is that if you were to use a table, if you were to use based on 16.48, right, then your Z value, okay, if P is 16.48, you will get negative 0.303 and 0.607. Slight difference in the answer, right? And it does make a difference because if you take 1 minus, okay, I'm just going to list out this answer for you for your reference because I know some of you may get a different answer as a result using 16.48 versus 47. So this is 3471. Notice 3475, 3471. This is different because this I'm using, my calculation is based on the P value that's 16.48. Okay, anyway, I've got a probability, but I haven't found the number of fish in the pond. The number of fish in the pond is basically the total number of fish, right? So we know that in simple probability, the probability of a certain event happen, right? PA, in this case, let's say A represent the probability of the fish having mass between 645 and 660. It's the number of fish having this mass divided by NS. NS is the size of your sample space. So if you take a probability of 0.3475, you take the number of fish and A, how many fish? 350, right? 350, you divide by your NS. So therefore, my NS is 1007. Yeah, if you use 75. Okay, now if you use 3471, then your NS will be, sorry, no space, man, 1008. Yeah, I think again, I take note, the answer in the textbook given is 1008. That's because your P value used earlier is 16.48. Okay, yep, I hope you're clear about this. All right, moving on to question number 6. So here the daily wages of workers in a factory, they are normally distributed, yeah, with mean of 80 ringgit, mu equals to 80, standard deviation is 15. Okay, so given the number of workers in the factory is 200, find the number of workers whose daily wage they're more than 85. So we take Px more than 85. We standardize it. This will be 85 minus 80 divide 15, which is 0.333. Again, you can use 1/3 if you use directly, right? So this will be 0.3696. Okay, you are finding what? You're finding the number of worker with daily wage more than 85 ringgit. Remember, use the same concept. Maybe number of worker, daily wage more than 85 ringgit. Yeah, divide by NS must equals to probability of event A. Yeah, event A is the probability, the event that the daily wage is more than 85 ringgit. So the number we do not know. All right, the total, your total number of workers is 200. You multiply with the probability 0.3696, I will get 73.94. Now, by the way, if you get 73.94, what do you take? Do you take 73 or do you take 74? I know some students will say, oh, there's only 73.9, not a full person, not a full worker, so we have to take 73. Now, I need you guys to understand this. If I were to draw this shape, the normal distribution curve, the mean is 80. Probability more than is 85 is here. So picture this. If you get 73.92, and some people say, oh, I don't have enough, not a full person, so I take 73. My total workers are 200, right? Okay, so if you take let's say I write 73.92, right? And when you take 200 minus, what do you get? You get 126.18. So should you round this up or should you round it down? Right, so this one you should round out to 74. This one you should round down to 126, so that your total, when you add up, it must be exactly 200. Understand? Huh? So please don't think, oh, not enough person, not a full person, it's half a person, so we take the smaller number. No, round off to the nearest integer will do. Okay, all right, that is my part A. Let's look at part B. Find the value of P if P percent of the worker earn less than 85. Okay, so this is the easier version because we only want less than 85. So I take 1 minus 0.3696, I get 0.6304. So my percentage is 63.04, just times 100%. Okay, by the way, again, there's a difference with answer in textbook. I think because the textbook uses z more than 1/3, so here they got 0.3694. If you get 36194, right, then your probability will be 6306. Then your percentage will be 63.06. Yeah, so there's a slight difference answer. Yeah, based on using calculator directly and versus using mathematical table. All right, we're coming to the end. Just so you know, guys, we have modules, right? Form 5 modules, Kssm, with a past year question, topical practice. Yeah, you can get in touch with us if you're interested in all this. All right, and you can even visit our Shopee site. Just search for Pusat Tuition Teliti, right? You can find all these books. Will be helpful for you if you need additional practice. Thank you for watching this video. I hope to see you guys in the next video.